All right, let's get right into it. Think about all the products we use every day, things designed to make our lives safer, cleaner. But what if one of the key ingredients, an ingredient that's supposed to protect us, actually comes with its own hidden risks? Today, we are going to unpack a really fascinating study that looked deep inside the brain to find out.
So take a look at this list. I mean, it seems kind of random, right? Socks, keyboards, bandages. You've probably used a few of these just today. But believe it or not, they all share a powerful secret ingredient, an invisible technology that promises to kill germs and keep things fresh. Any ideas?
The answer is silver. Now, for centuries, we've known that silver is a fantastic antimicrobial. But we're not talking about your grandmother's silverware here. We're talking about silver on a microscopic, no, even a nanoscopic scale. And that is where our story really begins.
Turns out, this silver lining might have a pretty serious downside. See, when you shrink silver down to these incredibly tiny sizes, its properties change. It becomes super effective at its job, but also potentially super invasive.
So let's meet the star of our show, silver nanoparticles, or AGNPs for short. To give you some perspective, a single human hair is about 80,000 nanometers wide. We're talking about particles that are just unbelievably tiny, which is exactly what makes them so good at wiping out bacteria.
Their tiny size is their superpower for sure, but it's also the very thing that's got scientists concerned. Because being this small gives them, potentially, an all-access pass to slip right by the body's most important security system, the blood-brain barrier.
And that leads us to the absolute crucial question here. These particles are in our socks, our keyboards, even our cosmetics. We're around them all the time. So what actually happens when this germ killer gets into the one place it really shouldn't be, day after day after day?
Well, a team of scientists decided to play detective. They set up this really comprehensive 90-day investigation to see what the effects of chronic, long-term exposure really look like.
Here's how they did it. It was pretty straightforward. For 90 days straight, they gave different groups of lab rats daily oral doses of these silver nanoparticles. The doses ranged from very low to very high to cover all the bases. And after those 90 days, the researchers took a really close look at their brains to see what, if anything, had changed.
So what did they find? Well, the very first signs of trouble weren't visible, not to the naked eye anyway. The clues were hidden deep inside the brain's incredibly complex communication network.
Before we dive into the data, here's a quick refresher. Your brain basically runs on chemical messengers called neurotransmitters. It's kind of like a super high-speed text messaging system that controls your mood, your movement, your memory, pretty much the whole shebang. If you mess with those messages, you're going to mess with how the brain works.
And here is the first really big finding. The researchers measured dopamine. That's a huge one for pleasure, motivation, and just moving around. And just look at the chart. It's so clear. The more silver nanoparticles the rats got, the more their dopamine levels dropped. It's a classic dose-dependent effect. And here's the kicker. The brain's dopamine system was incredibly sensitive. The study found that significant changes started to happen even at very low concentrations. So what that tells us is you don't need some massive dose to start messing with these delicate chemical signals.
But, scrambled signals were just the start of the story. The next question was way more serious. Are these nanoparticles causing actual physical damage to the brain cells themselves?
To figure that out, they measured something called oxidative stress. Honestly, the best way to think about this is like cellular rust. Like rust on metal. It's a process where unstable molecules start damaging cells, and it's a huge red flag for toxicity and degeneration.
And wouldn't you know it, just like with dopamine, the evidence was crystal clear. The more silver nanoparticles, the more cellular rust. This showed a direct, undeniable link between being exposed to these particles and the kind of stress that can lead to permanent damage.
Okay, and here's the visual proof. It's pretty stark. On the left, you're looking at a normal, healthy cerebral cortex. Now compare that to the image on the right. That's the same brain region after 90 days of a high dose. You can literally see the damage, the dark, condensed cells, the gaps in the tissue. Those are signs of inflammation and cells dying. The harm is no longer just chemical, it's structural.
And then they found this, the smoking gun. In the brain tissue of the rats that got the higher doses, researchers found these dark, clumpy particles. And what are they? They're believed to be the silver nanoparticles themselves, physically stuck, lodged deep inside the brain. They didn't just pass through, they got in and they stayed. So
After 90 days of chemical tests and looking through microscopes, what was the final verdict? What's the takeaway on being exposed to these nanoparticles long term?
The study's own conclusion, and I'm pulling this right from the paper, is pretty powerful. It says that signs of brain degeneration were seen starting from the very lowest dose they tested, just 10 micrograms per kilogram of body weight per day.
Let's be really clear about what that means. Since they found damage even at the lowest dose in their experiment, it means they couldn't actually identify a safe level of exposure. Every single group that received the nanoparticles showed some kind of negative impact.
This led the researchers to establish what's called a No Observed Adverse Effect level, or an NOAEL. And based on their findings, they had to conclude that this safety threshold had to be somewhere below that 10 micrograms per kilogram per day dose they tested.
In other words, they couldn't find a single dose in their study that had zero effect. The only truly safe level they could point to was a theoretical one, an amount smaller than anything they actually gave the rats. It just highlights how incredibly potent these nanoparticles can be on our central nervous system over time.
Okay, so why does a study on lab rats really matter to us? Well, because it raises these massive questions about the invisible ingredients being engineered into more and more of the products in our shopping carts.
And that really brings us to the final thought I want to leave you with. Look, nanotechnology promises incredible advances in all sorts of fields. But this research is a powerful reminder that, as the building blocks of our world get smaller and more powerful, our responsibility to understand their long-term effects, it only gets bigger. Something to think about, right?